We're in Pueblo, Colorado, on the Arkansas River, a levee realignment reconstruction for the Army Corps of Engineers and the city and state of Pueblo, Colorado. We've made our connection for dam number 2. As we go along, the excavator pushes up some gravel, so there's no way the AquaDam can get out of alignment. Three little mounds of fill right there. And as we go, we put fill because the one is slanted this way. The river bottom is. And the whole thing wants to drift that way. And this roll of fill out here is dictating what happens to the AquaDam. It's pushing off the toe of it underwater, not the top of it that you see, but the toe of it, and that's dictating things. They had to get out here with a cat and make things level. Now they've already removed this side of the river and pushed the whole thing over to this side of the river, and they did that before I was on site. And here's how you do it. You put gravel right there, and then you push the toe into it. And that right there keeps this in a perfect alignment. There is no guesswork. Nothing can go wrong this way. It's sitting in a little cradle, basically. And they're always leaving a head, keeping a head inside the AquaDam, from the top of the water to the top of the AquaDam. In this case, about 4 inches. And that's enough head to be in control, especially with putting all this, some fill behind it like they're doing here, which they're digging all this out anyway. He puts the dirt next to it and then shoves it with the front of his bucket and piles it into it. Each one of these units, this is unit number 2, is 250 feet long. This unit, we've got 160 feet to go. You just can't push the AquaDam over with the excavator. You got to put fill in after you do it. So this is how you get the fill up on the AquaDam. This is good gravel here. No rebar, no concrete. It's just natural gravel. You couldn't do this if there was broke concrete with rebar in it. Of course, the water pressure inside the AquaDam is unrolling the AquaDam. We got a late start today. We'll only end up doing 500 lineal feet. It's already 3 o'clock. And we're just putting the AquaDam, then we got to finish pumping it up. That'll take another hour. We got 6 pumps working. We've got 60 feet left to go on this 250-foot long roll. 5-foot high AquaDam. Of course, it's not finished being deployed. This AquaDam, so far we have less than 1 hour of pumping time into it, and it is going very smoothly. "40 feet to go." This is we're 20 feet from the end. This is the start of the collar, and the collar goes on the first dam that we're filling, and then by 15 feet, and 15 feet of it goes on the second dam that attaches to it. Okay, we're undoing the last 10 feet. We're going to shove it over a little bit there. That's it. Now we got a little pocket of air right here. We have to walk that air out.
If I put this on.
Now we're going to burp this AquaDam and walk the air out of it that the pumps put in. And there we go. Now this dam has to fill up. We'll be putting another one to the end of it. This is bag number 3, morning number 2. Taking off the outside wrap and the ropes that so we can unroll, remove the rope so we can unroll the AquaDam.
How we doing?
Well, that was wonderful. This is our third connection, or second connection, third AquaDam. Here's the connection collar, stops to here. Fill tubes come up through the holes we cut in the collar on top. Now we're inserting blue hose, discharge hose, into those fill tubes. We got 6 pumps running. The water level's about to go over right here. Once the water level, this breaks right here, it's going to flood this whole thing out. The water level here is the same as over here. They didn't build this high enough. This is going to fill in right through here. This is the dam we just put in. There's the next section. It's just one section, 250 feet long, to tie into the island. And then they'll have this channel completely blocked off, and they'll be able to cut the concrete below water line and pour new concrete from there up in the dry. Well, we're ready to put in the last dam, but it's been decided that that would be defeating the purpose. They want this water here to drain out, and it's draining through here. The elevation of the first dam is several feet higher than the elevation that this dam would be on. So we want to drain the water, not trap the water. So now they're discussing if they even need this last dam. And what they're going to do is cut even a bigger channel so this right here drains back into the river, which is over there. And it just wasn't deep enough. They had to go down another 12 inches. Oh, whoa, look at that. Whoa. Okay, the big decision was made to postpone putting dam number 4 in and see if we can watch this water drain out. We're going to go up to see if we can use this excavator to minimize leakage underneath the 750-foot first section of this dammed off area. The reason they're damming it off is so they can take out this concrete. It's got all this cracked here. The crack stops right there, and this is good, they say. So they're just stopping right there. They're doing a couple thousand feet of this levee. And of course they're going to tie into the existing levee with the new levee below water level. So they had to get the river off of the levee. Another view of the improved drainage so water can drain off the work site. This is the end of the 750-foot AquaDam. 3 pieces put together. The river water is at least 2 feet higher than the water on this side. Actually more than 2 feet. It looks like it's about 3 feet higher. This is the work area. Okay, this pump's running out of gas, so we're pretty much done pumping. on the first 3 AquaDams. Very little seepage coming underneath the AquaDam for as much disturbance that was done. So very, very little seepage. This area is dewatering itself quite nicely. The start of the AquaDam. $750 lineal feet in 3 pieces. This will soon be a dewatered work area. Then they'll have to pump out the remaining water.